Hi everyone, I'm Paul. I'm excited to talk to you today about pen plotting with Pluto. A plotter is a machine that you can program to move a pen around a page to draw whatever you want. The plotter that I have is an AxiDraw, which I'll show you later in my talk. But first I want to show you how I generate programs for it using Pluto and a library I wrote called penplots.jl. Penplots is a pretty small library, but it gives us some primitives that we can use to both create these pen plots and also preview them in the Pluto environment. The simplest data type is a point. And a point is just a standard x, y coordinate. As you can see, that's being pulled in from this Geometry Basics package. We can turn a series of points into a line with a path data type. And as you can see, it's rendered our path. All of the penplots data structures implement view for HTML, so they're previewed nicely right in the notebook. Penplots also knows how to render multiple paths. So let's create another path here. As you can see, it's rendered both of those paths in the same coordinate space. We can also use this technique to generate many lines programmatically. I'm going to use the map function to do so. As you can see, it's drawn 40 lines. On the bottom, it's going from 0 to 1 on the x-axis, and on the top, it's going from 0 to 0.5. The penplots library uses screen coordinates rather than Cartesian coordinates, so y equals 0 is at the top, and y increases going down. Just like we can use map to draw many paths, we can use map to draw many points within a path. I'll use that to make a simple circle. And as you can see, it's drawn a very basic circle. It looks smooth, but in reality, there's a bunch of very tiny lines that make this up. There's two new primitives from penplots that I'm using here. The first is UnitVec. As you can see, UnitVec is just a vector with 0x and 1y. There's also frac rotation. Frac rotation takes a fraction, a number between 0 and 1, and returns a rotation matrix where 1 will represent a full rotation and any fraction will represent some fractional rotation. Penplots also supports degree rotation and radian rotation. Let's turn this circle into a spiral. So far, this still looks pretty boring, but let's play with some of the parameters and see what we can do. I'm going to create a variable called step size that dictates how big each step we're taking is. With a very small step size, it looks the same as before. As you can see, certain step sizes create quite interesting patterns. I'm going to turn this into a function of step size. To plot multiple colors with a plotter, we need to physically replace the pen. To ensure we only have to do that once, we can group our lines into layers, with each layer representing one pen. So I've created a layered plot here, and I'm just going to pick some values of step size that look good. I think this would plot well, so I'm going to download it as an SVG. Now I can open up a tool called Saxi that's running on a Raspberry Pi connected to my plotter. And I can drag that in. And as you can see, it's created these two layers here. So I'm going to start with the first layer. Before I hit plot, I'll put in my pen. In total, each layer took about 10 minutes, so I've sped things up by 20 times. Between layers, I switch out the pen. The first layer went down nicely, but the second layer is kind of ruining it. And that's the thing with plotting. Sometimes you don't know if a design will work until you try it. I'm going to go back to Pluto and try something else. In addition to abstract generative art, people often use real images as an input to plotters. Since we can only draw lines, we have to be creative with how we represent the image. Fortunately, our brains are adept at recognizing images, especially faces, in patterns of light and dark, so we have a huge creative space of potential techniques to explore. As long as we make sure to put more ink on the page for the darker regions of the image will just appear. The technique I'm going to use is an amplitude modulating spiral. I'll draw a spiral just as before, but with a sine wave added to it. Then I'll overlay the spiral onto the image and vary the amplitude of the wave by the darkness of the pixel that each point in the spiral falls onto. As a result, the pen will cover more distance around the darker regions of the plot, and the source image will emerge. I'm going to start by recreating my spiral. This time I'm going to use a few parameters to control the frequency and amplitude of the modulation. Now I can write my spiral. And now we have a spiral, and as you can see, I can control things like the amplitude, the number of spirals, and the frequency of the wave that goes along these spirals. It's a little more clear now that this is just a wave going along these spirals. One thing that I kind of hand waved here is spirals is actually the distance along that we travel. So as we increase it, we do get more spirals, but in a way that's proportional to the square root of spirals, not the raw number. And the reason for that is that we want the frequency to be the same even as we go out. So if I don't do that, if I just make distance I, maybe I'll lower the frequency and the amplitude and the spirals. The problem here is that without the square root, the frequency is relative to the whole rotation. So as the spirals get bigger, the effective frequency goes down. So I'm going to put that square root back in. Okay, so now we have the spirals, but we don't have an image to overlay. So I'm going to load in an image. This is a picture of my wife, Sarah. It's color right now, but I want to make this black and white. So I'm going to turn this into a grayscale image. And so what we're going to do is overlay this spiral on top of this image, and then probe each point in this spiral for the brightness value in the image of that. So I'm going to write a helper function that probes the values. Images are stored as matrices, so each column comes first before the row. So we have to swap the normal X and Y order when we're accessing the values. So now we have this probe val function. I'm going to assign this as well, so that we have the access down here. I'm going to move it above these so that we can play with these sliders again. I'm also going to add a spiral called scale that's going to allow us to fit the spiral to the image. I'm going to move this up so we can see it. Now I'm going to pull the value out of the image when I create the spiral. And I'm going to multiply this value by the amplitude. Okay, our image has started to emerge. Looks like I forgot to do something. The brighter the image, the higher the value, so the higher the amplitude, but really we want the darker to be higher amplitude. So I'm just going to subtract from this. Now let's try decreasing the amplitude and increasing the frequency to see if the image emerges a bit more. There's one more thing I'd like to improve about this. Currently, I'm just probing the closest pixel to each point on the spiral. The problem with that is it picks up some of the noise in the image, and I'd really like to smooth that over. One approach would be to modify probe val to average over a certain area, but there's an even easier approach, which is just to pre-compute a blur on the image. I'm going to create a slider to control the blur. As you can see, the slider makes this more blurry. And the result is apparent in the spiral. This is what I want to plot, so I can download it. I'm happy with how this one turned out. I'd like to thank PlutoCon for having me today. If this talk has piqued your interest in plotting, feel free to reach out to me. I'm PaulGB on Twitter or paul@paulbutler.org.
Thank you so much, Paul. That was an amazing talk and a great start to the conference. It seemed like everybody in the chat really loved watching it. I actually saw this pen plotting stuff once before, and it's so cool to see the combination with Pluto. I guess some questions for me are, is there any Pluto feature that would be specifically useful to your application, like something you wish Pluto had?
That's an interesting question. I think one thing that I do right now is I actually end up generating the SVG twice. One is actually to embed in the little download button. So a native way to export an SVG or download an SVG would be really cool. But in general, I've just really enjoyed being able to kind of have some variables and then explore the parameter space pretty much live as a way to kind of explore these images. It's been great.
Yeah, and it's interesting that you chose Julia for this. Can you say something about that?
Yeah, so my programming background is mainly Python for the last decade professionally and kind of on my own. I kind of started using this as a way, when I saw Pluto, I thought, oh, this is a great way to get that interactivity, because a lot of the time what I would do is use a Jupyter notebook, and Jupyter has some interactivity, but I would find I would go back and just sort of make code changes and see how things looked. And so it seemed like a great chance to kind of try Julia out when I saw Pluto. And I also actually recently took sort of audited Alan Edelman's course on Jupyter with Pluto. So it tied in very nicely as I was learning that.
That's awesome. Okay, I would like to thank you again for your talk, and we will go on to the next talk. See you again, Paul.
Thank you.
All right. So